Good day, I am John Paul Arcilia, and today for this presentation I'll be showing you the basic operations of analytical chemistry. The scope of this video is about the use of analytical balance, quantitative transfers, measurement of aliquot and dilution, calibration of pipette, and lastly, reading and using of a burette. But before we proceed, let's take a look first on the proper laboratory attire. Make sure you wear gloves, face masks, closed shoes, and long pants, and don't forget to button your laboratory gown or laboratory coat. And now, let us proceed to the use of the analytical balance. First, check the analytical balance. Randomly collect 5 tablets from the bottle. Keep track of the identity of the tablets. Using a sample pan, weigh each tablet and record the mass on your notebook. Repeat this process 3 times to make 3 readings for each tablet. Set the balance again to 0, and this time, place all the 5 tablets and record the total mass. Remove each tablet, one at a time, and record each reading. Repeat this process by returning the tablet and removing it again for 3 times to make 3 readings. Determine the mass of each tablet removed by difference and record it on your notebook. Compare your results using the 2 methods of measurements. For the second part, let's now proceed to the quantitative transfers. First, using a beaker as a sample pan, measure approximately 0.400 grams of NaCl. Make sure to press the tare button before placing NaCl. Then dissolve the weighed NaCl using 20 ml of distilled water. Since we are using 5 ml pipette, we are going to pipette 5 ml of distilled water 4 times. Transfer the dissolved solution to a 100 ml volumetric flask. If you don't have any small funnel, to avoid spilling, use a stirring rod in transferring the solution. Wash the remaining solution in the beaker by adding more water to the beaker. Stir and transfer it again to the volumetric flask, following the same procedure. Repeat this washing until no trace of color of the solution remains. Record the number of washing made. Dilute the solution in the volumetric flask to the mark. Note that the lower meniscus must be on the mark measured at the eye level. Stopper the flask and shake the solution by making several inversions. Moving on, let us now proceed to the measurement of the aliquot and dilution. For the measurement of aliquot and dilution, carefully fill the pipette of the solution that we have prepared from the previous part of the experiment. Place the pipette tip well at the 250 ml volumetric flask and allow the liquid to drain. When the free flow ceases, rest the tip against the inner wall of the flask for 10 seconds. And finally, we draw the pipette with a rotating motion to remove any liquid adhering to the tip. Again, since we are using 5 ml pipette, we are going to pipette 5 ml twice. Dilute the solution in the volumetric flask to the mark. Lower meniscus must be on the mark measured at eye level. Stopper the flask and shake the solution by making several inversions, allowing the bubbles to reside on the top of the neck before making another inversion. Second to the last, the calibration of the pipette. First, for the calibration of pipette, clean a 10 ml or a 5 ml pipette. When a pipette or any volumetric glassware is cleaned properly, no droplets of reagents remain on the internal surfaces when they are drained. This is very important for accurate and reproducible results. Obtain a 400 ml beaker of distilled water equilibrated to room temperature. Determine the mass of the flask and the stopper. Next is to measure and record the temperature of the water. Pipette 5 ml of distilled water to the flask. Stopper the flask, record the mass of the flask and the water, and determine the mass of the 5 ml of water. In the same way, add a second 5 ml of water to the flask. Replace the stopper and once again record the flask with the water. Repeat this process until you have determined 4 consecutive masses of water. And for the last part of this experiment, the reading and using of a burette. After mounting a burette on a burette lamp, fill it up with the distilled water. The initial reading should be recorded after 30 seconds. Allow about 5 ml run into a 250 ml Erlenmeyer flask and wait at least 30 seconds and then take the final reading. Refill the burette and take a new zero reading. Add 30 drops to the Erlenmeyer flask and take the final reading. Calculate the mean volume of the one drop. Repeat this using 40 drops and again calculate the mean volume drop using half drop. Precision and accuracy and pondering in wisdom and sciences will nourish and develop a person's brain. And that's it for my video presentation. Thank you for watching.